Now next point is the magnetic field produced by a current in a circular arc of wire, right? Here we consider the circular arc of that wire. वायरचे आता वायर कशाच्या फॉर्ममध्ये असणार आहे तर एक आर्कच्या फॉर्ममध्ये असणार आहे, स्ट्रेट वायर नसणार आहे. ठीक आहे. मग हिअर dl is the small element of that arc. Now by using Biot-Savart law, how much is the magnetic field at the center of at the point O of this for this arc? Here we get, according to Biot-Savart law, dB is equal to mu0 upon 4 pi I dl sin theta upon r square, right? This is according to Biot-Savart law. What is the magnetic field at point O due to the entire arc? Here we get the magnetic field at point P. Suppose B is equal to integration of dB, right? Here you know that sin theta is equal to what? 1, because theta is the angle between the dl and r, which is 90 degree. Here sin 90 is 1. Here we get B is equal to integration of dB is equal to integration of mu0 upon 4 pi I dl divided by r square. Now what is dl here? dl is the small element. Now here we integrate dl, integration of dl is equal to what? It is the total length of the arc, right? But total length of the arc AB is equal to what? It is r theta, right? This is the formula for the arc. We know that here we get mu0 upon 4 pi constant, I is also constant and r square is also constant. Therefore here we get integration of dl only, and this integration of dl, it is the total arc length, and arc length of this AB is equal to what? R theta. Therefore we here we get mu0 upon 4 pi I upon r square into r theta. Here r get cancelled, the remaining formula becomes mu0 I upon 4 pi r theta, right? This is the magnetic field at the center of the r formula. Now by using this formula, suppose we consider the complete circle, right? For the complete circle, what happen? This arc is complete the circle. Here we consider this is the complete circle, and this is the point O at the center point. And here how much is the angle? Here we consider the simple arc AB. Now the angle described by the arc AB is here theta. So how much is the total angle theta for this complete circle? Total angle for this complete circle is 2 pi, right? Now for the circle, the magnetic field at the center point becomes B is equal to mu0 I upon 4 pi r into theta is equal to how much? Theta is equal to 2 pi. Here we get pi get cancelled. Here we get the B is equal to mu0 I divided by 2 r. This is the magnetic field at the center of the current carrying circular coil, right? But this is the simple formula. B is equal to mu0 I upon twice r, and this is only for the arc. Now next point. Now here we solve the MCQ. Here current I is flowing in a conductor shape as shown in this figure. Now the radius of the curved part is r and the length of straight portion is very large, right? Now the value of the magnetic field at the center O will be, here we have to find out the magnetic field at the point O, right? And that magnetic field is due to what? Here we find out the magnetic field at point B, and that magnetic field is due to, this is the curved conductor, okay? And this conductor is a long straight conductor, right? How to find out the magnetic field at the point O? Initially here we consider, suppose this is the point A, now this is the point B, and this is point C, and here we consider this is point D. Here ABC is the circular arc, right? And CD is the very large long straight conductor. ठीक आहे, CD काय असणार एक लॉंग स्ट्रेट कंडक्टर आहे, आणि AB जो असणार आहे ती काय असणार एक आर्क असणार आहे. ठीक आहे, मग आता O पॉईंटला मॅग्नेटिक फील्ड कशामुळे असणार आहे? O पॉईंटला मॅग्नेटिक फील्ड ह्या आर्कमुळे असेल आणि ह्या स्ट्रेट कंडक्टरमुळे असेल. ठीक आहे, हा एक स्ट्रेट पार्ट आहे आणि हा एक स्ट्रेट पार्ट आहे. तर आता ह्या स्ट्रेट पार्टमुळे आपण इथे मॅग्नेटिक फील्ड किती असणार ते डिसाईड करूया. ठीक आहे. मग आता ओ पॉईंटला फर्स्ट मॅग्नेटिक फील्ड कशामुळे असणार, ड्यू टू द आर्क ए बी सी. यू नो दॅट मॅग्नेटिक फील्ड ड्यू टू द आर्क ए बी सी इज हाऊ मच, B is equal to, suppose we consider this is the B arc. This B arc is equal to mu 0 I upon 4 pi r into what, theta, or this is theta is the angle described by this arc at the point O, and here that angle is how much, it is 3 pi by 2. So this formula becomes mu 0 I upon 4 pi r into 3 pi by 2. ठीक है. This is the magnetic field at point O due to the arc ABC. Now the magnetic field at point O due to the straight conductor CD. This straight conductor CD, this is the long straight conductor. ठीक आहे. मग हा लॉंग स्ट्रेट कंडक्टर आहे, त्याच्यामुळं O पॉईंटला किती मॅग्नेटिक फील्ड असेल ती कॅल्क्युलेट करायची. ठीक आहे. मग आपण एक पॉईंट फॉर्म्युला पाहिलं होतं फॉर द सेमी इन्फानाइट लॉंग स्ट्रेट कंडक्टर, द मॅग्नेटिक फील्ड ॲट पॉईंट ॲट अ डिस्टन्स, सपोज हियर R is the magnetic field due to the straight conductor. Here we get for straight conductor that magnetic field is how much, it is mu 0 I upon 4 pi r. Now this magnetic field is what, this is the magnetic field due to the semi infinite long straight conductor. ठीक है. Now this magnetic field is at a straight distance r. हे distance किती असणार आहे इथं, तर स्ट्रेट डिस्टन्स आर असणार आहे, म्हणजे आर डिस्टन्सवरती मी 0 I अपॉन 4 पाय आर हे त्याचं मॅग्नेटिक फील्ड असणार आहे. सो द टोटल मॅग्नेटिक फील्ड ॲट पॉईंट ओ इज हाऊ मच, टोटल मॅग्नेटिक फील्ड बी इज इक्वल टू बी आर्क प्लस बी स्ट्रेट. ठीक आहे. मग आता मॅग्नेटिक फील्ड किती होईल या ठिकाणी, बी किती आलेला आहे, मी 0 I अपॉन 4 पाय आर इंटू 3 पाय बाय 2 plus here we get mu 0 I upon 4 pi r. Here we get common mu 0 I upon 4 pi r is common, then answer becomes 3 pi upon 2 plus 1, right. Which option is correct here, C option is correct, mu 0 I upon 4 pi r 3 pi by 2 plus 1. Now next point is the axial magnetic field produced by current in a circular loop. Here we consider the circular loop, but here we find out the magnetic field along the axis of that circular coil. Here suppose this is the circular coil, right, or the circular loop, and current I is flowing through this loop. Here this is the small element dl of the loop, and here we find out the magnetic field along this axis and at point P. Now this point P is at a distance z from the center of the circular loop. Now how much is the magnetic field dB at point P due to this small element dl? According to Biot-Savart law, here we get dB is equal to mu 0 upon 4 pi I dl sin theta upon r square. Now how much is the theta here? Here theta is the angle between the line joining the point and small element dl. This angle is here 90 degree, right. This theta and this theta is different. Here angle between the small element dl and line joining the point is 90 degree. So the formula becomes dB is equal to mu 0 upon 4 pi I dl upon r square, right. Now which is the direction of this magnetic field? Here according to right hand thumb rule, direction of this magnetic field is in outward direction. ठीक आहे. या डायरेक्शननी मॅग्नेटिक फील्डची डायरेक्शन असेल, आणि आपल्याला मॅग्नेटिक फील्डची डायरेक्शन फाइंड करायची आहे कशाच्या अलॉंग, तर ॲक्सिसच्या अलॉंग. मग ॲक्सिसच्या अलॉंग मॅग्नेटिक फील्ड फाइंड करताना जो काय हा मॅग्नेटिक फील्ड dB आलेला आहे त्याचा कंपोनंट घ्यावा लागेल व्हर्टिकल. ठीक आहे. व्हर्टिकल कंपोनंट ऑफ दिस मॅग्नेटिक फील्ड dB. मग सपोज दॅट व्हर्टिकल कंपोनंट इज डिनोटेड बाय dBz. तो किती असेल, dVz असेल. मग dBz चा फॉर्म्युला काय असेल, हियर dBz is equal to, this is the vertical component of magnetic field dB, but that vertical component becomes cos theta of dB. ठीक है. और here we write this is dB cos theta, this is dB cos theta. What is dB cos theta? This is the vertical component of magnetic field dB, right. Now by solving this, we get the magnetic field along the axis of this circular loop. That means Bz is equal to integration of dBz or the integration of dB cos theta. Here we put dB is equal to mu0 upon 4 pi I dl upon r square, right. Now by solving this mathematics, we get the formula for the Bz is equal to mu0 I r square divided by 2 times z square plus r square bracket raised to 3 by 2, right. Here this is the formula for the magnetic field along the axis of a circular loop and at a distance z from the center of the सर्क्युलर लूप. ठीक आहे, सिंपल फॉर्म्युला आहे, थोडंसं मॅथमॅटिकल कॅल्क्युलेशन आहे याच्यामध्ये, पण हा फाइंड आउट करायला सोपा आहे. नाउ नेक्स्ट पॉइंट इज द मॅग्नेटिक लाइन्स फॉर द करंट लूप. हियर वी कन्सिडर द करंट लूप and current I is flowing through this loop. Now what is the direction of this magnetic lines? Here the direction of the magnetic lines is in a upward direction. Now these magnetic lines are from downward to the upward through this loop. ठीक आहे, मग आता हा ॲक्सिस आहे, ॲक्सिसच्या अलॉंग मॅग्नेटिक फील्ड किती असणार आहे, ॲक्सिसच्या अलॉंग किंवा सेंटर पॉईंटला मॅग्नेटिक फील्ड किती असणार आहे त्याच्यात. Now these are the magnetic lines produced by the current carrying circular loop. Now last point we find out the magnetic field along the axis of this circular loop. Now this is the axis of this circular loop. ठीक है, at distance z we find out the magnetic field. Suppose we consider this is the point P. Now at point P the magnetic field is what? Bz is equal to mu0 I r square divided by 2 times z square plus r square bracket raised to 3 by 2. Now how much is the magnetic field at the center of this circular loop? Now at the center of this circular loop, here we put z is equal to 0. That means this distance is 0, therefore the point P is at a center. So how much is the magnetic field at the center of this circular loop? Here Bz is equal to mu0 I r square divided by 2 times 0 square plus r square, we get r square bracket raised to 3 by 2. Here 2 get cancelled, we get r cube, and here r square also, here r square and cube get cancelled, the remaining formula is mu0 I. Here we get Bz is equal to mu0 I upon 2 r, right. But this is the magnetic field at the center of the circular loop, right, and this direction indicate the direction of a magnetic lines, right. This is also very simple formula. Now next point, Ampere's law. Now what is the Ampere's law? This is also very important law in this magnetic field due to electric current. Now what is the Ampere's law? In this diagram we see that this is the Amperean loop, this is the imaginary loop around this current carrying conductors. Here current flowing through this first conductor is I1, this is I2, this is I3 and this is I4. Now what is the direction of the current for this 4 conductor? We know that this symbol indicate that this conductor is perpendicular to this plane and in outward direction. Similarly this direction is also in outward direction, but I3 direction of this current is in inward direction. Similarly I4 is also in inward direction, right. But for this Amperean loop, the current flowing through this loop is only I1, I2 and I3. Now by using this right hand thumb rule, what is the direction of this magnetic field? Suppose direction of the current is indicated by the thumb, then curl finger indicate the direction of magnetic field. Now here we indicate the direction of a magnetic field. Now what is the Ampere's law? Now for this imaginary loop, the line integral of the magnetic field, is proportional to the current enclosed in this loop. Here we suppose consider total current enclosed in this loop is suppose I enclosed. Okay, this is the current enclosed through this current loop, and here the line integral of the magnetic field, that means integration of B bar, integration of B dot dl is proportional to the current enclosed through this loop, right, and the total its value becomes closed integration of B dot dl is equal to mu 0 times total current enclosed on that loop, right. Now here we consider the total current enclosed in this loop are I1, I2 and I3, but here I4 is the outside the loop. Therefore, formula for Ampere's law to this diagram becomes closed integration of B dot dl is equal to mu 0 times I1 plus I2, and here direction of I3 is opposite to the I1 and I2, therefore here we get minus I3. Here we cannot get the I4 because it is the outside current for the loop, right. So the Ampere's law becomes for this loop is mu 0 times I1 plus I2 minus I3. Okay? This is also simple law. Now next point is the magnetic field of a solenoid. Now this is the schematic diagram of a cross section of current carrying solenoid. We know that the solenoid has, suppose here the n number of turns, and this diagram indicate here this is the direction of a current in each loop. Here this direction indicate that current is in outward direction, and this direction indicate that current is in a inward direction, and this is the Amperean loop, right. This is the Amperean loop, and here the magnetic field of this solenoid is B is equal to magnetic field of this solenoid is B is equal to mu 0 n I. Now what is n here? N is the number of turns per unit length. What is n here? N is the number of turns per unit length of the solenoid. These are the number of turns. Mu 0 is the permeability of the vacuum. I is the current flowing through this solenoid. Remember this formula, B is equal to mu 0 n I. Now this is the application of the Ampere's law. Now second is the magnetic field of a toroid. Now next point is the magnetic field of a toroid. This is also the cross section of the toroid diagram. Now here these are the direction of the current. Here this direction indicate that current is in a outward direction, and here current is in a inward direction. That means this is the loop of the toroid or the loop of the wires, right. Now here radius of the Amperean loop is capital R, radius of the Amperean loop is capital R, and magnetic field is suppose B. So how much is the magnetic field for this toroid? Here B is equal to mu 0 n I divided by 2 pi R. This is the formula for the magnetic field of a toroid. What is capital N? Here capital N is the number of turns, and R is the radius of this Amperean loop or the mean radius of the toroid, and I is the current flowing through this toroid. So the formula becomes B is equal to mu 0 n I upon 2 pi R. Here n upon 2 pi R is also the number of turns per unit length of the Amperean loop, right. Remember this, capital N upon 2 pi R, this is the number of turns per unit length of the Amperean loop. Here 2 pi R is the circumference of this Amperean loop, right. Now here we solve this MCQ. An electron moving in a circular orbit of radius r makes n rotations per second. Now the magnetic field produced at the center has magnitude. Here we have to find out the magnetic field at the center of a circular orbit. Now radius of that orbit is how much? Radius of that orbit is r, and its frequency is n rotations per second. What is n here? N is the frequency. That means here we get n is nothing but it is the reciprocal of time period, right. And the radius of circular orbit is how much? R. Now we know that the magnetic field at the center of the circular orbit is how much? B is equal to mu 0 I upon twice R, right. This is the magnetic field at the center of the circular current carrying coil or loop. Now in this option what we see here, charge on the electron is E, radius of the orbit is r. Now what do we see here again, the frequency n. ठीक आहे, मग हा फॉर्म्युला आपल्याला कशा पद्धतीने कन्वर्ट करता येईल जेणेकरून जे ऑप्शन दिले त्यानुसार त्याचा आन्सर असू शकतो. ठीक आहे, मग हिअर करंट इज व्हॉट आय, चार्ज इज ॲन इलेक्ट्रॉन. ठीक आहे, चार्ज काय दिला आहे, एक इलेक्ट्रॉन दिलेला आहे. ठीक आहे, आणि त्याची फ्रिक्वेन्सी आहे एन रोटेशन पर सेकंद. ठीक आहे, पर सेकंद दिलेली आहे त्याची ती फ्रिक्वेन्सी असेल. आता करंट आपण इथं कसं डिफाईन करू शकतो, करंट आय इज नथिंग बट दी इट इज द रेट ऑफ लॉ ऑफ इलेक्ट्रिकल चार्ज, दॅट मीन्स आय इज इक्वल टू ई अपॉन टी. And we know that the reciprocal of time period is nothing but the frequency, that means current I again becomes E into n. What is n here, n is equal to 1 upon t. ठीक है, now put here I is equal to En. What we get the formula here, B is equal to mu 0 En divided by twice r as it is, right. फक्त काय केलं मी इथं, करंट आय ची व्हॅल्यू ई अपॉन टी घेतली, 1 अपॉन टी म्हणजे एन असेल फ्रिक्वेन्सी. मग हिअर वी गेट करंट आय इज इक्वल टू ई एन, मग मॅग्नेटिक फील्ड बिकम्स बी इज इक्वल टू मी 0 ई एन अपॉन ट्वाइस आर. सो विच ऑप्शन इज करेक्ट हिअर, हिअर डी ऑप्शन इज करेक्ट, that means मी 0 एन ई अपॉन ट्वाइस आर. ठीक आहे, दिस इज वन ऑफ द सिंपल MCQ.